Okay, we're going to look at some limit practice and review. So we're going to do the front page together just to review those different methods, and then you're going to complete the back page problems. So number one, we're just going to try substitution first. So when I straight up just plug in 3, I get 5, right? 2 times 3 minus 1 is just 5. In example 2, I'm plugging in infinity, so I'm looking at dominant terms. The numerator wins. When I plug a negative number in, if I cube it, I get a negative number, and I square it, I get a positive number. Negative divided by a positive will approach negative infinity. So again, I'm plugging in infinity. The powers are equal, they're both linear, so I'm going to strip the coefficients and get 2/3. This time I'm approaching -2, which is going to be a vertical asymptote from the right-hand side. So I should really look at the graph to see what's going on. So I'm going to do parentheses x plus 5 divided by parentheses x plus 2. And I'm looking at -2, which is here, from the plus side, so from the right side. So this graph is shooting up towards positive infinity from the right. If I had asked you for the overall limit at -2, you would say does not exist because the two ends of the graph are approaching different amounts. Let's see, in example 5, the powers are equal. We're approaching infinity, so we would strip the coefficients and just get 3 as our limit. In example 6, -2 is going to be undefined when I plug it into the denominator. So what I need to do is factor the numerator, so I'm using difference of squares, and factor the denominator, so I'm using the diamond method. I just did it in my head quickly. So I was looking for the factors of 6 that added up to 5. 3 times 2. See how those x plus 2's nicely cancel? Now I can plug -2 in. I get -4 divided by 1, so my limit is approaching -4. So if you can't plug something in, you need to see if you can factor and cancel. Same thing in example 7. I can't plug -3 in. So let's see, if I factor, I'm going to have x. I'm looking for the factors of -15 that add up to -2. That'd be what, x plus 3, x minus 5. X plus 3, x plus 3. So there's good news and bad news. The good news is one of the x plus 3's cancel. The bad news is I still can't plug in -3. So what I do is I can go to the graph and I want to look at x minus 5 over x plus 3, the new function. What's happening at -3? So at -3, the ends are going in opposite directions. So this time the limit just straight up does not exist. In example 8, I can't plug in 0. I get 0 in the denominator. So I'm going to factor out an x. So I'd have x times x minus 2 over x. When I plug in 0, I get -2. Example 9, I can't plug in 0. So I'm going to multiply this out using FOIL. So x minus 4 times x minus 4 minus 16. I'm going to get x squared. Outer plus inner gives me -8x. -4 times -4 is plus 16, and I'm subtracting 16. So therefore, my numerator is x squared minus 8x divided by x. So I can divide an x out of each term. So I just am left with x minus 8. Now when I plug in 0, I just get -8. Example 10 has a radical, so I'm going to do the conjugate method because I can't plug in 0. So the conjugate means you take the opposite sign of what you had over here. The minus becomes a plus. So square root of x plus 1 plus 1. The magic happens when you take the square root times the square root. You just get x plus 1. The outer and the inner terms are opposites and add up to 0. -1 times 1 is -1. So there's your x on top. I'm just going to rewrite it down here. I have x on top, and I have 7x times the square root of x plus 1 on the bottom. Feel free to pause it to catch up. Cancel those x's, so now I have a 1 in the numerator over all that stuff. I'm plugging in 0 right here. This becomes 1 plus 1, which is 2 times 7 is 14. So I get 1/14. Again, if I went through too fast, just pause the video as you write it down. The last thing I wanted to go over, when you're looking at a graph, what does all this mean? So as x approaches 0 from the left, I'm looking at this part of the graph right here. It's approaching 0. As x approaches 0 from the right, I'm looking at this part of the graph right here, which approaches 2. What's the overall limit at 0? Does not exist because one end was approaching 0 while the other end was approaching 2. Let's do the same thing at 2. 2 from the left. Here's 2, here's from the left. It's approaching -2. 2 from the right. It's approaching 0. Overall limit does not exist. Let's see, 4 from the left. Here's 4. Well, from the left, it doesn't look like there is any function there. But I guess this arrow says it continues, right? So 4 from the left, I would guess maybe 3/4. 4 from the right, also approaching 3/4. I'm estimating here. So the overall limit at, oh shoot, I'm looking at -4. Let's look at 4. 4 is over here. So from the left, it's approaching 4. From the right, it's approaching 4. Even though the value does not exist there, it's approaching the same thing from both sides, so the overall limit is 4. And now you're going to try the guided practice on the back page.